for joining us. Today we have Peter Borica with Alcoma presenting the webinar. He's the sales manager at Alcoma. If you have any questions, please input them in the question box and Peter will answer them at the conclusion of the webinar. At this time, I'm going to let Peter take over, and I hope everybody enjoys the webinar.
Good morning, good afternoon to everybody. I don't know from where you are. Welcome to the Alcoma webinar. In the beginning, I would like to say thank you to Microcom for having this opportunity. Thank you to Crystal for organizing this webinar. I would like to take the first 20-25 minutes of webinar for presentation introducing Alcoma and its products, and the last 5-10 minutes discussion. Who is Alcoma? Alcoma is not a new company. Alcoma is now a company with more than 20 years history, and it's based on the knowledge of military research during communist period in Czechoslovakia. After fall of communism in 1993, my father, together with 3 of his friends, started Alcoma. They have more than 30 years experience from military microwave research. Until now, Alcoma is owned by Czech shareholders. It's a Czech company with more than 65 employees. We have 2 plants in Czech Republic. One is in Prague, and the second one is in Kolín. It's a city about 50 kilometers far from Prague, where we produce 80 gigahertz microwave transmitters and receivers. As I told you, company started in 1993, and it had one big customer, the first and the biggest customer until now, whose name is České radiokomunikace. He was one of the 2 operators during communist era, so it's a company with very long history and a lot of customers. After fall of communism in 1993, this company ordered the first links in 10-11 gigahertz. So Alcoma started with 1 customer and 11 gigahertz frequency band. Since that time, we spread our production. Today we start at 4 gigahertz and go up to 80 gigahertz. Our main market is still domestic. About 60% of production is sold in Czech Republic. About 40% is exported to more than 50 countries within almost the whole world. To have some experience how big we are, we produced more than 25,000 terminals during those 20 years. Last year we produced more than 3,000 terminals, and the increase from 2012 to 2013 was about 20%. Last year, probably this time, we met with American company RF.com, and we agreed that they will help us to enter US market. So we started with NEMCO certification in March 2014. We finished certification of the first products. Now it's a good time to start selling. Alcoma as a company has only 4 main activities. It's development of radio relay links, manufacturing of radio relay links, installation and service of radio relay links, and some project services which are based on local basis only for Czech Slovak republics for the Central Europe. What do we produce? Alcoma, since its beginning, produces only point-to-point carrier-grade microwave radio relay links. I will switch to the third slide. And you can see that we can split the production horizontally and vertically. In fact, we produce all outdoor links and split ODU IDU links, and we produce free band links and license band links. Today we will mainly talk about all outdoor links, which name for the United States is Zenit. For the rest of the world or on our website you can find the very similar products under the name of MP400. In general, this Zenit line brings you easy installation of the link with only one cable to the outdoor unit, which serves for power feeding, for management, and for user data. You have also possibility to have two independent Ethernet channels. Two independent Ethernet channels can be connected either by one metallic and one optical cable, or by two metallic cables, or we also have a possibility of 6 pairs cable which can connect one fast Ethernet and 1 gigabit Ethernet channel. The Zenit link has in-band and out-of-band management possibility. It has surge protector both in outdoor unit and in indoor unit. The power feeding can be from 20 to 72 volts direct current. You can use either one power feeding power supply, or you can use redundant power feeding with 2 power supplies. So as I told you, Zenit is all outdoor compact designed radio relay links. It consists of outdoor unit which is connected to the antenna, and so-called protected interface box. This is, I don't know if you can see it, but this is this passive component which brings you possibility to join power feeding with user data and management data, and having only one cable from this protected interface box to outdoor unit. Antennas 1, 2, 3, and 4 feet antennas are also produced and designed in Alcoma. All Zenit links have built-in spectrum analyzer. This is especially very necessary for free bands. So in 24 gigahertz Zenit 24, you can check the received frequency and tune properly the right channel not to interfere with other 24 gigahertz link. As an option, you can have AES encryption. It's AES 256. For all Zenit frequency bands up to 24 gigahertz, it's only a software option, and it can be ordered anytime. For Zenit 80 in 80 gigahertz, there's also a little change of hardware, and it must be ordered when you order the link. There is also option to have more than 1 gigabit Ethernet ports. As I told you, you can have 2 or 3 gigabit Ethernet ports, from which 2 can be totally independent. Zenit main features. We were the first who brought to the market 112 megahertz bandwidth modem with 1024 QAM. It was almost 1.5 years ago. The maximum user data throughput is 900 megabits per second. I'm talking about that because today everybody announces 224 QAM and the same bandwidth, but we really have it. We have it more than 1 year. FCC frequency bands which are being certified at the moment are 6, 7, 11, 24, and 80 gigahertz. We plan 18 gigahertz for the fourth quarter of 2014. Modulation schemes of the link are starting with QPSK, and you can switch up to 1024 QAM. The link has incorporated hitless ACM, adaptive coding and modulation, and this adaptive coding and modulation can react for very fast dynamic changes of surrounding conditions. If the surrounding conditions are changing with dynamics up to 100 decibels per second, the ACM still should be hitless and should be able to switch between modulation schemes. Channel sizes are starting with 5 megahertz, going up to 80 megahertz, 112 megahertz for Zenit 24, or maybe Zenit 11 if you can join 2 56 megahertz channels. For Zenit 80, we use 1250 megahertz. Output power for license band is or can be set between -10 to +20 dBm for license band, and from -25 dBm to +5 dBm for license exempt Zenit 24. You can set the output power either manually, or you can use ATPC, automatic correction of transmit power. The Zenit links serves as an Ethernet bridge. It's transparent, it doesn't process. Its Ethernet is carrier Ethernet standard, L2 transparent alternative to metallic or fiber optical cables. So what goes to the link you received on the other end of the link. The Ethernet line parameters are independent on transmitted protocols, so you can easily mix different types of protocol, different packet lengths, and it has no influence to the capacity, to the transmitted capacity. Once more, in the default configuration for US market, Zenit has one metallic and one fiber optical Ethernet interface. As an option, we can add the second metallic interface, but this is an hardware option and it must be ordered in advance. There is also always a possibility to use the 6 pairs cables, and in that case, even with one grommet for metallic cable, you can use one fast Ethernet channel and one gigabit Ethernet channel. If you have more than one Ethernet channel, you can either join them to one channel and use it as a switch, or you can set by software settings those two channels to be fully independent and use them either for two different customers, or one can be used for service channel, diagnostics channel, and the other one can be used for user data. There is also a possibility to use one channel, for example, for IPTV, and the second channel for the rest of traffic. What is very, I think, good feature is that if you split the traffic to two channels and use, for example, one channel as IPTV channel, you can guarantee its capacity even if the link is switching under bad weather conditions. So you can set this channel as guaranteed channel, and if there is any ACM switching, you can it takes capacity only from the second channel, and the guaranteed channel has full capacity as long as possible. The second channel has always some minimum capacity, which is about 1 megabit per second. So it's never stopped, but it can be almost stopped. The link is ready for triple play services, so you can mix web services, IPTV, and voice over IP if you need, without any influence to link parameters. Link can be also used in 1+1 configuration, and it can be configured either by the same device from Alcoma or different device from Alcoma, or it can be backed up by any other device. The link is able to be set to shut down the port, the Ethernet port, in case of failure, and you can switch the data either by your equipment, or the link itself can switch the data to the second Ethernet port. The maximum MTU is 10,240 bytes. In fact, there are two configurations. The basic configuration allows 2,048 bytes MTU. The other configuration allows 10,240 bytes packets. It can be set in the diagnostic software. What I forgot to say, if you split the Ethernet to two independent Ethernet channels, you have two possibilities how to assign their capacity. Either you assign it fixed by telling the first channel has 40% of the total capacity, the second channel has 60% of the total capacity, for example. You can change it anyhow, or you can assign it dynamically. So in case one channel needs more and the second channel is empty, more capacity can be assigned to the channel which is full. As I told you, Ethernet can bring you AES 256 encryption option. The Ethernet can bring you QoS, and it also can bring Q&Q possibility if you want to use it. The next slide is about mechanical design. The Odoo itself is a black box, and there is only one little user space with two punching blocks, which is accessible to the end user. We use punching blocks, not RJ45 connectors, because we designed our first all-outdoor link more than 10 years ago, and we found that punching block gives the link more reliability, because all the parameters, including independence, are fixed forever. They don't change when somebody drags the cable or in case of any mechanical problem. The optical interface connector is the other connector which is accessible to the user, and the second connector which is accessible to the user is RSSI connector, which gives you voltage for pointing. The second part of Zenit Link is so-called indoor protected interface box, which is in fact a passive component with incorporated lightning protector, and it has one or two metallic Ethernet inputs, one or two power feeding inputs, and one or two grommets for SSTP cable for interconnecting this protected interface box with outdoor unit. The power feeding is either plus or minus, doesn't matter, volts, direct current. The power consumption is between 25-35 watts, depending on frequency band. So for Zenit 24, it's 25. If you have Zenit 6 or Zenit 11, it can be 35 watts because of higher output power. The voltage which should be on the punching block of the outdoor unit should be between 20 and 70 volts. The next slide is about antennas. Alcoma produces its own antennas, 1, 2, 3, and 4 foot antennas from 6 gigahertz up to 38 gigahertz, and 1 and 2 foot antennas for 80 gigahertz. The antennas are lightweight, compact design with fine pointing. They have some lifting points for easy installation. To have some imagination about weight, the 1 foot antenna without outdoor unit has about 4 kilograms. The 4 foot antenna without outdoor unit has a little less than 30 kilograms. Because we designed antenna in Alcoma, we also thought about packaging. So packaging of antennas is effective to achieve low transportation costs. 1 foot antenna is packed 1 per 1 box, but 2, 3, and 4 foot antennas are packed 2 in 1 box. They are little disassembled, but you save a lot of money on transport. We also can deliver a polarization coupler for 6, 11 gigahertz, and also for 24 gigahertz. 18 gigahertz will be also available when we launch 18 gigahertz Zenit in the United States. Because the time's passing quickly, so several words about management. Management is a topic for separate webinar. But what is important? Alcoma management is being done via independent processor in independent service channel. Sorry, so it has no influence on user data. The main management program, so-called ASD, is program which works with proprietary protocol, which is very robust, and it can work up to bit error rate 10 on -2. With ASD, you can get a real-time status of either link or the whole network. The biggest network which is under one ASD server control has more than 1,000 links, and their status is updated in less than 1 second. So as I mentioned, we have either ASD in local or network mode, which is installed to one computer, and we have also ISD server, which is based on SQL database. SQL database communicates directly with all the links. It polls parallelly the whole big network, and users are connected to this SQL database. This SQL database can also serve as a interface to another system, either SNMP based or any other system. The interface is open and can be changed either by Alcoma or by the company itself. ASD brings you very good safety, because when you want to connect to the link, you must pass through several authentication processes. One is login to the program, the second one is login to the link. You can also save the link by so-called user code, so you can have BSD with user code and link with the same user code. If the link has user code, it cannot be managed by ASD without the same user code. So even in the case of collocation on one tower, you can safely manage your links if you have user code within those links. Zenit has also its own SNMP protocol incorporated, and it has also some easy web interface for basic TCP/IP settings. Each outer unit has also RS-232 possibility to connect to the link. So that's briefly everything about management. The last topic is tools for design and installation. Even though we don't produce professional tools, I think we can give you two very useful tools for design and installation of the link. The first one you can find on www.alcoma.com. It's Alcoma Web Link Calculator, which has two different modes. One is standard mode for easy design. The second one is advanced mode, where also latitude, longitude can be put, and it calculates not only with rain zone, but it also calculates with multipath and other problems than rain. And we have also a little smartphone link calculator, so if you don't calculate your data in advance and start installing link, you still have a possibility to calculate all needed data if you download the smartphone calculator. At the moment it's ready for Windows Phone and for Android, and soon it will be also available for iPhones. So in fact it's all about technology, it's all about Alcoma. There are only two more information I want to tell you. Oh, one more I forget is a little example. This is radio relay network in Czech city Spa Lázně, Františkovy Lázně. It's combination of metropolitan area and corporate area network. It was built about 10 years ago on free band. There is more than 20 links working almost all on the same channel, and how to explain it, sorry. So the area is about 1 times 1 mile. So in such a small area, more than 20 links working on one channel were planned, and they work more than 10 years without any problems. Last information is about sales contacts in the United States and Canada. So at the moment we have Microcom Technologies as a distributor. Microcom has currently 24 gigahertz unlicensed radio on stock, so it can be delivered very quickly, and you can contact Microcom either by phone or by email by sales@microcomtech.com. And Alcoma also has its own technical support, US-based support, so you can contact our US-based technical support by email. And you can also contact directly Alcoma help desk contacts, but keep in mind that the time difference is between 6 and 9 hours. So there will be probably next day response. That's all from my side. Thank you very much for your attention. And now we have several minutes for discussion, hopefully.
All right. That was fantastic. Thank you, Peter. Let me go over these questions. First question is, can you give us an example of price for hardware and shipping for a 24 gigahertz link with 4-foot antennas to north central U.S.?
Okay, I can give you the price of link can be maybe given by you, and I have calculation of transport of 4-foot antenna transport. But if you can give me your email contact, I don't know it by heart. I think it was about $400 per the whole link with antennas for transportation, but I'm not sure. I would like to give you the exact number by email if possible.
Okay. The next question is, can you ask when the customer purchases a model with an Ethernet and fiber port, how do the cables work to power the radio?
The radio is powered by, or can be powered either by STP cable together with the metallic Ethernet, and if you don't want to use metallic Ethernet at all and you want to install only fiber optic cable, and there is a connector for direct power feeding, so you need a cable with 2 wires, and you can directly connect it to power feeding connector in the outdoor unit.
Okay, perfect. All right, next question. What competitive advantage does Alcoma have over comparable radios?
Okay, it depends what we want to compare. If we want to compare Zenit 24 with Ubiquiti, so the Ethernet is real Clear Ethernet standard. The capacity is real user data capacity. The output power is the real output power. The ACM is real hitless ACM. If we want to compare with, I don't know, SAF, so there is probably only one big advantage at the moment, and it is that you can achieve 112 megahertz 1024 QAM. So as I know, SAF today has available 60 megahertz bandwidth with approximately 400 something megabits per second full duplex. We can deliver within Zenit 11 or Zenit 24 900 megabits full duplex. I don't know, I think that's the main advantage.
Okay, fantastic. Next question. Does the Zenith use Ethernet header compression, or are there plans to add that to improve the speed slightly closer to a 1 gigabit?
It uses some type of header compression. The capacity we talk about, so 900 megabits per second, is capacity for 1.4 megabytes package. So in case you use smaller packets, the capacity increases significantly. So we work with header compression, and the real capacity is dependent on the packet size, in fact. We will improve it with the next generation of Zenit. Next generation is planned for 2015. What we can give you as an example, if you can, or maybe I can send directly to Microcom the RFC tests of Zenit 24, so you can see the difference in capacity between small packets and big packets.
All right, perfect.
In fact, if I can have 10 more seconds, the capacity for 10 kilobytes packets is almost those 900. It's not significantly less than 900. It's 800, I think 70 something.
Okay,
So,
perfect. Also a recap to the last question. Alcoma has the highest bandwidth radios on the market and available today at Microcom. And we have one more question. Well, they just keep coming in. So when you say 900 megabits full duplex, is that an aggregate of 450 by 450 or 900 by 900?
no, it's 900 megabits full duplex, so it's 1.8 aggregate.
Okay. Next question. Have you tested your 80 gigahertz radios against Ciclu and Bridgewave?
Okay, against Bridgewave, I don't know, the radios are probably very similar because Bridgewave is a real adult radio with high output power, with full duplex, more than 1 gigabit throughput. So I think that Zenit 80 is comparable to Bridgewave. If we want to compare it to Ciclu, we are comparing two different products because we are comparing the, I think, street level based Ciclu with very low output power. I don't know what they declare, but I think, as I know, the real output power is about 5 dBm. If we talking about the half duplex or semi-duplex Ciclu, only 70 gigahertz Ciclu, so this is not carrier grade radio. Maybe the 80 gigahertz, 70, 80 gigahertz Ciclu is carrier grade radio, but still with low output power.
Okay. Do both ends of the link use duplexers and so are fixed to be high or low?
Yes. Each of the units has a duplexer inside and it's either high or low.
Okay. I'll give everybody a second to get in any last questions. All right. It looks like we answered everybody's questions. So thank you, everybody, for attending the webinar this morning. Hold on. We got one more. The duplexers field changeable, so only one radio can spare both ends of the link.
In fact, yes and no. It depends. They are not designed as field changeable, but they can be changed by technical staff with some experience. In fact, the microwave part is the same, and changing diplexer in lab is easy. In field, I am not so sure. So they can be changed by experienced staff. They can be changed by our US-based technical support.
Okay. All right. All right, we got to thank you. I think we're good. Okay. Thank you, Peter, for taking the time out of your day to educate us on this great line of products. If anyone has any additional questions, feel free to contact Alcoma at their contact. You can contact us at sales@Microcom Tech. If you wish to view any of the products mentioned here today, you can visit us at www.microcom.us or contact your salesperson. This webinar will also be posted on Microcom Technologies' YouTube channel for later review. Thank you, Peter. Thank you, attendees. I hope everybody has a great day.
Okay, thank you, Crystal. Thanks to all. Have a nice day.